All right, welcome everyone. So today I'm going to be talking about GNU Shepherd and some thoughts that I have on freedom and software freedom. Specifically about this war that's been waging in the Linux wasteland on systemd. I think it's a very silly like a war that people wage. I can't even understand the point. But anyway, I'm going to be talking about those topics. So for those not aware, just to give you context, I use GNU Guix, Guix system. It's one of the certified operating systems from the Free Software Foundation, and it is it's very different than other Linux distros in the sense that you actually can swap the kernel. It's declarative. You have a language. It's very similar to NixOS. But it's very different in the sense that it doesn't use Nix, the language. It uses similar concepts, but slightly different. That makes it very unique, and I really appreciate it. It feels very interactive because it uses Scheme. It uses Guile, actually. So it's an operating system I truly like, and I use it. In fact, this one is a Geek system. And it comes with some differences than other Linuxes, in particular with the init system. So most people are used to swissmd, right, or systemd, and S6, CSV init, what else? OpenRC. Like usually those are the contenders, right? And there's this useless war that I see people waging, and I think Luke Smith already made a very good video on the subject, debunking essentially the idea that, oh, systemd is low, systemd is bloated. And technically, I don't have anything to add on that. I do subscribe to his analysis. I don't think systemd is particularly bad software. You may argue that it's potentially bloated software, that it has colonized half of the user land. You can make those statements, like you can say like you don't like, I don't know, journaling. That's one example, who knows. So maybe you would advocate to debloat systemd. I don't have a particular problem with bloat. I use Emacs. In fact, this year is running my Emacs instance. I actually like bloat if it's good bloat, right? What I don't like of bloat is web bloat and like a React website to generate, I don't know, to show like a pudding on the screen. Like I don't like bloat on the web usually, or some bad software like, I don't know, the Claude code trash. Like you just have a TUI and then all of a sudden it's a React engine. It's a game engine, man. Like sorry, that's just scoping for bad software. So so just to make it clear, I'm not against bloat if it's good bloat. What is good bloat then? Well, Emacs is good bloat in the sense that it has a uniform interface to communicate through the things that it has, and it follows a very good abstraction, which is it's a list machine, right? So I can literally just inspect variables in my Emacs, and I can basically say, let's see this guy here. So I click on it, and then I have this value. I can see the value is set to nil. I can see what it does. And then if I want, I can even follow the source code and try to understand what it is about. This is a living interactive environment, so I am invited to explore my system. Of course, there are systems that we use Unix, like this whole thing is built atop of Unix. And Unix is a very unfriendly system, operating system to, or abstraction at this point. Linux is just system-like. Is Unix-like, but it's a very unfriendly. It doesn't abstraction. It doesn't invite you to explore, and I think this is the core concept that I am trying to argue on my article. But just to try to sum it up here, the idea is that once you explore things, there's a difference between just being a passive user and an active user, right? So a passive user is somebody that, for example, is just a baker. Let's put it that way. So imagine you're a baker and you're running some accounting software for your business, and you have the source code. It's free software, all good. And then you hand over. That's why you have distribution of software, right? So you hand over that software to somebody else because to extend it with features and give you back the changes because you don't actually understand how to read the code, right? The language it's written in or something like that. You're a baker. So the idea with free software is to create a community around the solver about this piece of software, right? So you can hand over that piece to people that are specialized in their labor and provide improvements to the overall benefit of the community. So I totally approve that idea. The only issue I see with applying that is that when you have just the source code of, let's say, the Linux kernel, well, that is good because I can extend it and I can potentially remove spyware or other things that I cannot do with Windows nor Mac OS. The only issue I have with that is that it's a very static-like system, right? So the abstractions that it builds upon, they do not invite you to open the room and look around. And those do not truly empower the user. Like, they certainly permit action, right? But permitting action is, to me, analogous to having a button on a room, right? So you can say there is an empty room and then there's a button on the room and that I can press the button, right? But the button doesn't do anything. Like, I'm not truly empowered by having a button there. It just doesn't do anything. It permits action. It's much better than if I were not allowed to press the button, but the button doesn't do anything. It's like I have the stux here and I can squish it, but it doesn't do anything in particular. It just suffers my abuse, but squishing it won't solve anything or incur in any other actions. So I would say that empowerment is something like a Smalltalk or a list machine. So it is being able to not only browse the source code, but also be actively invited to explore what is presented to you. And this is part of an architecture decision. And I think this is something that no init system nowadays offers. And I want to see more software. This is not only a problem with init systems, by the way. A lot of other pieces of software do not do that. But I want to see more of other more systems doing it. So I was writing here, now going to GNU Shepherd, I was trying to define my Postgres service, right? So I just wanted to have my own Postgres instance running on this machine so I can basically modify and do some stuff. So I just had some services. So you can see it's all scheme, right? So it's all homo iconic and everything. So I can literally just use these modules here for like databases, some services for the home manager, and some services for actual Shepherd. And then I can basically modify and add my own services. And then I added like a vacuum here just to try it out. So you can do all sorts of stuff. One thing that I think is fascinating is that I can open a REPL. Right. So this is fantastic. Because a REPL means that I can do stuff like, so for example, this is the interface, okay? Actually, let me show you GNU Shepherd before we do that. So this is the website. So the Shepherd herd system and user services, keeping you in the loop. You configure it and extend it in scheme. That's the idea, right? So it gives you an interface like this. It feels very systemd-like. So for those aware of systemd, you basically just do like systemctl or something like that. You can do like status, enable, and so on, don't recall. But you can manipulate the thing and poke it around, right? Poke the services. You can do the same here. So I can check if my REPL is on and it is stopped, right? I can start, and then check it again, and now it's running, right? So you can manipulate your program that way. This is an interface to explore it. But you can do more than just that. So what you can do is, I need to evolve this. So you can do this. This is my Emacs, like as just some tiny script to do it. So you can evaluate with Geyser, or Geyser, don't even know. You can connect a REPL into my session. And by connecting the REPL, you can basically treat the service object, like the the service that is providing the REPL as a environment where you can take an abstraction of those programs that are running. So on any init system that I am aware of, you just manipulate photographs, right? So when I do like herd status REPL or herd or like systemd or some openrc or something like that, you're basically poking the thing and taking photographs. The state of the program of the service changed already. So every second, every microsecond, the state is already different. It's a living thing, right? But you're just treating the snapshots of the thing from the outside. The idea is to have also a representation, but instead of just a static photograph, you actually have a reference to the thing that you can manipulate as your user. So let's open this function here on this, let's call that. So that is Shepherd remote control, and there we go. So you can see this is a GNU guile, right? So this is an actual full-blown environment. I can do all sorts of things that I can do on Scheme, right? But more importantly, I can use stuff like, I can import modules, and I can do stuff like this. So what this code is doing is essentially just just doing a for each on each service and printing their name and their status, right? So we can evaluate that, and there we go. So we have, for example, Pipewire, like a bunch of audio stuff. We can have our Postgres service that is down. I can have my GPG agent. So you can see all the services that I configured on my declarative interface, and they're all here. So I can manipulate them like this. So now PG is in my hands. I can manipulate the service, and it's a service object, right? So I can ask things to this thing. So actually, this is better. So I can ask you, are you running? And it's not running, right? I can see the actions that it has. So I can ask it to perform actions, right? So I know that it has health, it's an action, and it just returned me ready. It's just a dummy action, by the way. You can register other things. So this is one example where I'm basically declaring what you do when you start, what you do when you stop. And then I think here I configure the vacuum, so how to run the vacuum DB, like on my instance, right? How to dump, so you can do like backups like this. So anyway, you can do all sorts of stuff and manipulate this in your environment. The whole point here that I'm trying to make is that all of these tools, they're trying to invite you. I think there's this talk that is fantastic. It's from a guy that went on Strange Loop. I'll try to find the link. He said, his talk, I think, is the small talk lurking in the C and Unix. And of course, all of this is also possible to be done in C and Unix, but the systems are very hostile. They're not meant for that, right? I think he shows one example where he embeds a bunch of stuff in a C using the debugging to actually do the browsing of the internals. But when the system is very hostile, it turns to be very antipathetic to the user. It is not actively inviting the user to observe the internals and manipulate its state. It's instead shooing away the user to go home and find something better to do, right? So it's not the kind of thing that I think we should be following. In fact, my whole point about bloat is that I don't mind if something all these arguments of systemd is bloated, I don't think they particularly matter. I'm pretty sure they can be perfectly reasonable taste expressions, right? Definitions of your taste, but I don't think they're objective arguments that help anything on the discussion. They're just a matter of opinion, of taste, right? So I think the main argument that I have for something like GNU Shepherd, not that it is bloated, it's very lightweight, but the idea is that it could be bloated. That doesn't really matter, because the point is that the abstraction is so much better that to me, it would supersede the fact that it may be bloated, right? So I think the arguments should be being done that way, from that angle. And I just wanted to make a statement on that. So that's basically it. Thank you very much.